Hey guys, Saion Gupta here, founder at 10x Coder Kids and an official Guinness record holder for the youngest computer programmer in the world. And today we are going to be understanding and coding out the Wagner Fischer's algorithm. Alright, so we are going to be understanding it and we will be coding it out. So, what is the Wagner Fischer's algorithm? The Wagner Fischer algorithm is used to find how many operations will it take to go from a certain word to another word. So, for example, if you want to change boats into float, the Wagner Fischer algorithm will tell us how many operations will it take to do that. All right. So over here, I have created an Excel sheet for you so that we understand better. Right. So we have an empty space and an empty space over here, and then we have the float and boats word written over here. Right. So what we are doing over here, how did 0 come over here? Basically this is saying that if we want to convert from this empty space to this empty space, then how many operations will it take? But as both are the same, 0 operations are needed to be performed. Next we are seeing converting an empty space to the letter F, right? So we need to perform one operation, right? Next, converting an empty space into FL, right? So that will take 2 insertion operations, because when converting to F, we needed to insert F. That was one operation. So when converting to FL, we need to insert F, and then we also have to insert L, right? So this will take 2 operations, 2 insertion operations. Next, converting it to FLO, so 3 insertion operations, then 4 insertion operations, then 5 insertion operations. Similarly, next what we are checking, we are saying converting B into an empty space, so that will be one deletion operation, right? So you're deleting B. Next, converting BO into an empty space, right? So that will be 2 deletion operations. Then converting BOA into an empty space, so that will be 3 deletion operations. Then converting BOAT to empty space, so that will be 4 deletion operations. Then converting BOATS to an empty space, so that will be 5 deletion operations, right? So we get 0 1 2 3 4 5, and we get 0 1 2 3 4 5 over here. And this is the case for like all the words. So if you had to convert from high to buy, then what you'll do, you'll get 0 1 2 3 over here and 0 1 2 over here. Right? So this is the same for all the words, right? So we get 0 1 2 3 4 5 and 0 1 2 3 4 5. Next, we had to convert B into F. So as you can see, we just need to substitute B, right? So we just have to substitute F for B, right? So we have to replace B with F, right? So that's one substitution operation. Next, over here, what we had to do, we had to convert B into FL, right? So what operations do we need to make? We had to substitute F for B and then insert one L. So those are 2 operations, right? But if we try to program this, it won't be that easy. So there's a trick. What's the trick? Basically, find the minimum out of these 3 cells. So to find the value over here, find the minimum out of these 3 cells. So in this case, it's 2, right? And then add 1 to it. So we get the value of this cell. Same over here. Find the minimum for this. To find the value of this cell, find the minimum of these 3 cells. So it's 3, and then add 1 to it, so get 4. Then to find the value of this cell, find the minimum out of these 3 cells. It's 4, add 1 to it, so we get 5, right? Next, over here, to find the value of this cell over here, what do we have to do? We have to basically we already found the value of this cell, right? So we already found the value of this cell. To find the value of this cell, sorry about that, we already found the value of this cell in the first step when we added 0 1 2 3 4 5 and 0 1 2 3 4 5. So now next we have to find the value of this cell over here. So how are we going to find it? We're going to check the value, the minimum value, that is 1, and add 1 to it, so we get 2. Next, over here to find the value of this cell, find the minimum value, that is 1, and add 1 to it, that is 2. Next, to find the value of this cell, we'll find the minimum value over here, that is 2. But you are seeing we did not add 1. Why didn't we add 1? As you can see over here, O is same as O, right? So changing O to O does not take any operations. The only operations that are required to be done are changing B to FL. And we saw that it can be done in 2 operations only. So we'll write 2 over here, right? We won't add 1. So the trick over here is that when there are the same values, do not add 1 to it, only find the minimum value, right? So for the next cell over here, we'll find the minimum value, that is 2, add 1 to it, we'll get 3. Next, find the minimum value, we get 3, add 1 to it, we get 4. Next, over here we already found 3, so over here find the minimum value, that is 2, add 1 to it, we get 3. Then find the minimum value, that is 2, add 1 to it, we get 3. Then to get this, find the minimum value, that is 2, add 1 to it, get 3. Next, we are getting 2. Why? Because over here we have A and over here we have A. So we are just going to find the minimum value, that is 2, right? So, and we are going to add 2 over here. Next, to find this cell's value, we're going to find the minimum value, that is 2, add 1 to it, and we'll get 3. And so on, we are going to do this, right? So we are going to use this trick, and we get the distance, right? So we get the distance, like we get the number of operations in which boats, we'll convert boats to float. What's that number, right? So we have to ultimately, what do we need to find? We need to find the number of operations in which we can convert boats to float. So that number is the last number over here, right? So it's the last number over here. Very, very, very cool. So now by using this trick, we are going to be coding this out, but first we are going to fill this table ourselves. So we have 0 1 1, find the minimum value, that is 0, and add 1 to it. So we'll add 1. Then 1 1 2, find the minimum value, 1, add 1 to it, we get 2. Then 2 2 3, find the minimum value, we get 2, right? And add 1 to it, that is 3. Please note there is no same letter. So we have high and by. So there is no same letter. So we'll always add 1 to the minimum value. So between 1 1 2, the minimum value is 1, add 1 to it, we get 2, right? Then 1 2 2, the minimum value is 1, add 1 to it, we get 2. And from 2 2 3, the minimum value is 2, add 1 to it, we get 3, right? So 3 will be the answer. Why? Because you are going to replace H by B, so one substitution. Then you are going to replace I by Y, that is the second substitution operation, and then you are going to insert an E. So that's the third operation, that is insertion, right? And over here also, when converting boats to float, there is 3 operations. How? If we see, deletion of S, that is one operation. Then basically replacement of B to L, right? So you're going to replace B, right? And basically substitute B for L, right? And then insert F at the start. Or you can do vice versa. You can like replace B, substitute F for B, and then insert L in between F and O, right? So those are three operations. One, deletion of S, second, insertion of L, or you can insert F, and third, substitution of F or L, right? Very cool. Now we are going to be coding out this algorithm in JavaScript, right? So I have this script.js created, right? And we are just going to create a variable matrix, an empty array, right? So we are going to create a matrix that will be our grid, right? Next we are going to set the word, right, that is equals to our boats that we have to convert. So boats is the word to convert, and variable word to go, like we have to go to, word to go to. Right? So variable naming can be done better. We are just going to name it word to go to, right? And that will be float, right? All right, very cool. We are going to say the variable distance equals to 0. So this will be our distance variable, or let's just leave the distance for now, right? We are just going to focus on the grid. Now we have to fill in our matrix, right? So we have to make our matrix that will be a two-dimensional array, right? So to fill the matrix, what we are going to do, we are going to loop for variable I equals to 0, and we are going to say I less than word.length, that is boat's length, right? And I plus plus, right? So we are looping on boat's length, that is 5. So we loop 5 times, right? We are going to create an empty array, right? So that will be inserted in the matrix, right? So 5 arrays will be inserted in the matrix, right? Next we are nesting, we have nested loops because we have to create a two-dimensional array. Variable j equals to 0, j less than word to go to dot length, right? Word to go to dot length, and j plus plus, right? So now we are looping on float, right? And we are just basically, for now, we are just pushing array dot push. We are just pushing 0 for now, right? So we are just pushing 0 for now, and then we are going to say matrix over here dot push array. So if we check out, if we open this in a new tab, go to the console and check our matrix, so this will be a two-dimensional array, right? So an array consisting of 5 arrays, and each inner array will have 5 elements. Very cool, right? All right, so we have the base matrix. Now what we are going to do, we are going to basically now loop once again. So we are going to say variable I equals to 0, I less than word to go to dot length plus 1, right? And I plus plus, and we are going to say matrix 0 I is 0 I is equals to I. Why? So I and Y, sorry about that. So why are we doing this? Because in the start we saw 0 1 2 3 4 5 inserted, so we are basically adding that 0 1 2 3 4 5, right, from this loop. So if we check the matrix now, we will have 0 1 2 3 4 5, right? So if we check the matrix, so we have 6 elements in the first array, 0 1 2 3 4 5, right? So ideally I should have created this a 6 by 6 array, right? I've created it a 5 by 5 array. I should have created it a 6 by 6 array. So let's just do plus 1 so that it's symmetric. Matrix. So now we have our 6 by 6 array, right? Next what we have to do, we have to insert this 0 1 2 3 4 5, right? So how are we going to do that? We are going to say for variable I equals to 0, I less than word dot length plus 1, I plus plus, and we are going to say matrix I 0 is equals to I, right? So now 0 1 2 3 4 5 will come over here also. So if we check our matrix, so 0 1 2 3 4 5, 0 1 2 3 4 5. Now you might be wondering, why didn't I club this into one single loop? Why are we looping 2 times? That's because we can have a case like hi and bye, where the number of letters in the word to convert and the word to go to are not the same, right? So the number of letters may vary. So that's why we need 2 separate loops. All right. Next we will have our main code logic for variable I is equals to 1. Why 1? Because I'm just going to tell you in a second. First let's write this out. Word dot length plus 1, the same loop that we had above of this one, just we are saying I equals to 1, right? And I plus plus. Inside this we are going to have for variable j is equals to 1, j less than word to go to dot length plus 1 and j plus plus. I'll just explain this in a second. Let's just write this out. So we're just going to, now what we have on this cell over here, we'll have 3 cases, this and this. So we are going to save the value of these 3 first. So we'll have case 1, that will be matrix I j minus 1. So basically this will access this element, right? So on the same row, right, but on a column just left to it, right? So this will I j minus 1 will access this value, right? Variable case 2 is equals to matrix I minus 1 j minus 1 and all right, variable case 3 is equals to matrix I minus 1 and j, right? So these are our 3 cases. Next what we are going to say that now I'm going to explain why this we have set as 1 and 1. Because if we said 0 and 0, then we are trying to basically get the values around this 0th element, right? We will be trying to get the values around this 0th element, but the element who are around whose we want to get the values. So basically we want to get in the start 0 1 1, right? We have to find the minimum values out of 0 1 1, right? There's no point going on this element over here. We have to start from this element, right? So we have to start from this element, not from this element, right? So that's why 1 1 will bring us to this element. That's why I have given 1 1, not 0 0, because then it would start from this element, but we have to start from this element. All right, so matrix I j is equals to math dot min, the minimum value out of case 1, case 2 and case 3, right? The minimum value out of case 1, case 2 and case 3. Next, now we have to figure out the increment. We will only increment if the corresponding letters are not the same, right? So we will only increment if the corresponding letters are not the same. All right. So in this only we'll write an if statement. So if word I minus 1, because we are starting from 1, we are accessing using indexes, so they start from 0, that's why we are doing I minus 1 is equals to word to go to j minus 1, right? So if word I minus 1, because we are when we are looping this, we are first going from this and checking all of these, then we are going this and checking all of these, then we are going over here and checking all of these, right? So if word I minus 1, so we are going to use I for word, and word to go to j minus 1 is, if they both are equals to, then we are going to do nothing. So we are going to do nothing else matrix I j plus equals to 1, right? So I j plus equals to 1, so add 1 into that value. All right, and then we are just going to, this was our matrix, console.log matrix, right? So if we run this, we will have our completed matrix, right? And over here the last value is 3. So cool. Only 34 lines of code and we have coded this. Let's just go through it once. We had the matrix, we had boards, we had float. Oh my god. We had float, right? We looped, we filled the matrix with zeros over here, right? Then we added 0 1 2 3 4 5 in the first row, we added 0 1 2 3 4 5 in the first column, right? Then we are looping on the word, that is boards. Then inside of that we are looping on float, right? So because we are first going on B and checking all of this, then we are going on O and checking all of this, then we are going on A and checking all of this, right? So we are like looping on word first, and inside of that we are looping on a float, right? And then we are taking out the 3 cases, that is for this element, this and this, taking the minimum value and setting over here the minimum value, so in this case 0, right? Then checking if this letter is equivalent to this letter, it isn't, so adding 1 to it, right? And this is how it went through, and in the end we have the full matrix that is over here, that we had over here, right? So cool. We just coded the Wagner Fischer's algorithm in 34 lines of code. Now let's check this with high and buy. For example, we want to convert high to buy, right? So over here we had 3 in the end. Let's see what we have. We have 3, 0 1 2 3, 1 1 2 3 and 2 2 2 3, the same exact matrix that we wrote in the Excel sheet we are getting through our Wagner Fischer's algorithm in JavaScript. And guys, I hope you like the video. If you have any doubts, please don't forget to comment. I'll surely answer them, and I'll see you in the next one.